start the recording and start class. So we are in Unit 2, so Unit 1 is done officially. That's great. So this week we have two sections, 10 and 11. They're very closely related, 10 and 11, both dealing with conversions. You do have, it's called a report because it does not require Excel. I know some people have already turned it in, but you can use Excel if you want. You are not required to. You can use a Word document or whatever you want. But there is a video in section 11 that does a problem exactly like what you're being asked to do in that dosage calculation assignment. So if you watch the videos for the packet, you should find it. If you need help locating that, let me know. Then we have the quiz and the discussion board. So that's just kind of what to do this week. I would like to start with just any questions or feedback from exam 1. I do go in and regrade those. Hopefully you noticed that the grade that it said you got at the end and the grade that is now in IB Learn should be different. I go through it and grade things, look at your scrap paper, that sort of thing. So does anybody have any feedback or anything that they would like to share in regards? And if you don't feel comfortable sharing in this open forum, feel free to email me your feedback. But the only way we're going to make this class better is to get feedback from you. So any comments, anything from the group regarding exam 1? Okay, I'm going to go with that's a no. So we'll just move on. Okay, so section 10 deals with conversions. So we are going to start with the conversions. It will be very helpful if you have page 245 from your packet handy. Page 245 is actually, it's a yellow page in your packet, and that is our formula sheet. So for both exams 2 and 3, you will be allowed to have that formula sheet with you. Well, not that one. A formula sheet just like that will be provided to you at the exam. So you don't need to bring it with you. But anyway, it's important that when you're doing your work, you're using this formula sheet because that will help you become comfortable with where things are located and how that all works. So there you go. Okay, so with conversions, we are going to use what we call identity ratios in our factor label method. An identity ratio is simply a ratio that is equivalent in the numerator and the denominator, but has different units. For example, 7 days is 1 week, right? This is an identity ratio because 7 days and 1 week are the same thing. Now, the thing with identity ratios is that they can all be written 2 different ways. So we could write this same identity ratio as 1 week over 7 days, right? Same numbers, same labels, just flipped. And we're going to show why that's important as we work through some of these problems. So when we talk about identity ratios, this is just what I mean. A ratio where the numerator and denominator are equivalent. Oh, gosh darn it. Shannon, I muted you because I was getting some background noise and you hadn't muted. So if you could mute yourself, that will allow you to then mute and unmute. There you go. Okay. And Diane, I also muted you, so that's that. Okay. All right. So let's just go ahead and you're very welcome. Let's go and jump into our first question. So my pedometer said I walked 11,520 feet yesterday. How many miles is this? Now I really want us to get in the habit of showing the process. If you think, oh, that's a one-step problem, I'll just plug it into my calculator. While that might be true, you're going to get to some problems that are multi-step, and if you don't understand the process, you may struggle. So with this, we always want to start with what we're given. So we're going to start with 11,520 feet. And we're dealing with ratios. Ratios are fractions. So I want to write this as a fraction. Now, with that being said, I want to get rid of feet, right? I want to change feet to miles. And when you go through this, you kind of want to have the mindset of you want to let your labels guide you. So when I look at this problem, I have feet, and I want to get rid of feet. So if I think about fractions and reducing fractions, I can reduce numerator to denominator. So feet right now is in the numerator. To get rid of it, I'm going to put them in the denominator, right? I'm just thinking labels at this point. So I know that I can change feet to miles. So my identity ratio is going to be feet to miles. And after you have your labels in order, then you can think numbers, right? And I know from my page 245 that 1 mile is the same as 5,280 feet. So I now have my identity ratio in here. My feet are going to cancel out, and I'm just left with miles. So since this is the label that I want, I'm ready to do my math. So a quick tip, if all the non-1 numbers are in the numerator, you just multiply. Well, this 5,280 is in the denominator, so I will have to divide. And the reason I'm going to divide is that if I would multiply fractions as we know how, which is multiplying straight across, I would get 11,520 divided by 5,280. To simplify that, I would divide. So you can also think of this as you start with the 11,520. Because the 5280 is in the denominator, we would divide by 5280, and that would give us an answer of approximately 2.18 miles. And that's kind of the process we want to work through with all of these problems. Factor label method. We use identity ratios with labels to work through these problems. Okay, and this is a one-step problem. This one would be considered probably an easier problem because it's only one step. Right? So the next problem, we're going to do a multi-step problem. If you have questions, you need to stop me. Otherwise, we're going to just keep motoring. Because this can be a long 2 sections. So in number 2, I bought a gallon jug of juice. How many cups is this? All right, so we start with I bought a gallon, right? We know that a gallon is 1. So I'm starting with 1 gallon over 1. Okay, I want to go to cups. When you look at your formula sheet, can I go straight one step from gallons to cups? No, you are correct. That was very quick, Vanessa. Good. But gallons can lead me to what? Quarts, exactly. So we want to kind of say our first step is to say 4 quarts is 1 gallon. And remember, it's all about labels. Because I want to get rid of gallons, the gallons have to be top and bottom. And now my label is quarts. All right, I still don't want to be in quarts. So to get rid of quarts, I'll put them on the bottom. What can I change quarts to? Pints, exactly. So 1 quart is 2 pints. So the yellow step will get rid of our quarts. I'm still not where I want to be. So what's my last step? Cups, right. 2 cups is the same as 1 pint. And it's all about positioning, right? Because now the pints will cancel out. So it's really important that you keep your labels in your problem as you're working through these because you need it to work. Now, if you notice, all of my numbers, 4, 2, and 2 are all in the numerator. So how many cups would be in this gallon of juice? 16. You have an extra, Brooke, you have an extra 4 in there somewhere. Right, we started with 1. This is a 1 gallon. So 1 times 4 times 2 times 2. And that gives us with, good. Glad you found what you did there. So just 16 cups. But it's going to be very, very important that you have this process because this is all about process. And some of them will definitely be easier than others, but if you understand the process, it'll allow you to do the hard ones a little easier. Okay, so I'm going to have you guys try one. I bought a 17.3 pound turkey. How many ounces is this? So go ahead and try this one. Let's go nearest tenth. Nearest tenth. Sorry about that. That's a good, very good question. Hopefully you discovered that on the exam, that rounding does matter. All right, so good answers coming through. So let's just type this up real quick so those watching later can see. 17.3 pounds. We want to get rid of pounds and go to ounces. And as people showed in there, yes, we have 16 ounces in 1 pound. Change color for effect. That makes my pounds go away. And we multiply, and as all of you said in the chat box, 276.8 ounces. Excellent. Okay, so that's the US customary, right? Most of us, you know, if you get the process, we can probably do a lot of those because we've been living in that world. Well, we are now going to talk about the metric unit. Okay, so we're going to kind of change gears a couple of times today. So in the metrics system, everything is base 10. You can use the factor label method with fractions, but really that's just a lot more work. So when you think about the metric system, we have, let me get a pen here, we have liters, right, which gives us the L, so liquids. We have grams, and we have meters. So unlike the US system, which has different terminology for weight, volume, and distance, the metrics use the same, you know, prefixes, you know, kilo, hecto, deca, deci, centa, and milli, and it's just the L, the G, or the M based off of what you're talking about. Well, because we have this, and if you look at on page 245, the yellow sheet, the second box down, they give you this on your conversion sheet. So if you can count, you can convert in the metric system. Let me show you an example. We're going to change 380 centimeters to hectometers. So when you're looking at this, I'm starting in centimeters, which is here. I want to go to hectometers, which is circled. So to go from centa to hecta, I have to go left, right, because I'm starting here. And I'm going to go left 1, 2, 3, 4 positions. Left 4. So that basically, yes, Noah, exactly like a decimal point. And that's exactly what my next sentence was going to be. Just like when we talked about scientific notation, left 4 is the number of places and the direction that we would move our decimal point. So if we're starting with 380 up here, right, you don't see the decimal, so it's at the end. And I'm going to go left 4 places. 1, 2, 3, 4. So that open hump at the beginning is a 0. So 0, 3, 8. Again, remember with web work, it likes a 0 in the front. So 380 centimeters is the same as 0.038 hectometers. It's all about counting and moving. So again, I started on the centimeter, start there, and you just count the sections. All right? Yeah, once you know how to do it, it's not bad at all. Okay, you guys try this one. 4.5 kiloliters to deciliters. Yep, answers are coming in. So you're starting on kiloliters, moving to deca. So 1, 2, 3, 4 places to the right. So 1, 2, 3, 4, which means we got 3 zeros. So 45,000 deciliters. Good. Amanda, you lost a 0 in yours there. Hopefully that was a typo and not a thing. Let's do one more of those. 5 grams to centigrams. Go ahead and try that one. So remember, grams would be considered the base unit, so that starts in the middle, and we want to go to centigrams. So I have to move right. Starting on the unit, I go right 2 places. So if I start with 5, 2 places to the right gives me 500 centigrams. Is everybody okay with working within the metric system? Good. Okay. All right. So the last part of section 10, I call it jumping across the pond. So if you watch any of the rest of my videos, that's how I refer to it. So basically what that means is working between the US customary version of measurement and the metric system, and being able to go from, inches to meters or inches to centimeters or pounds to kilograms, that kind of thing. Yeah, like skipping stones, exactly. So the thing is that, we have different, if you look at your yellow sheet, it's the third one down, and there are different spots of jumping, if you will. So sometimes you're going to have to convert within the US system first before jumping, and then you might have to work again in the metric system. So you really have to let your labels guide you of what you're going to do next. All right. So I weigh 170 pounds. What is that in kilograms? So this one is pretty straightforward, right? I have 170 pounds, and if you look at your yellow sheet, you'll notice that you can go from pounds straight to kilograms. We don't have to do any other pre-work. It is important that you use the conversions on that sheet, because that is what your WebWork homework was built off of. So we're not using the 1 kilogram is 2.2 pounds, right? That's a health thing, and I get that, but that's not what's on our formula sheet. So we really want to use the 1 pound is 0.4536 kilograms. So yeah, and no, I agree with everything that you just typed there. Okay, so that makes our pounds go away. We just multiply across. Again, don't forget this decimal point here in the middle. And as stated, we have 77.111 kilograms. So just a touch over 77 kilograms. So I always say, if you ever are, you don't like the number on your scale, just convert it to kilograms and you'll feel a lot better about your weight, right? Kind of a different things. So I would consider that an easy one, because it's one step. And when you can just do one step, that'd be great. But if we needed that answer to be just in grams, well, then we would have just moved the decimal after we got that kilogram answer, right? So you use the skills that we learned with the US customary and with the metric, and you apply it where you need to. So, okay, you guys try an easy one. You guys try this one. My trophy is 170 centimeters tall. How many inches is this? I call it an easy one if it's one step. Shannon. Oh, I also got 112. My bad. Noah just didn't round that last one up. So Shannon, you're good. 77.112 would be the appropriate rounding of that problem.
Por el Samsung 7 con activación y el plan y todo eso. Porque le están quitando como $120.
Crystal, you're going to want to make sure you mute yourself when you come in. I just muted you. No problem. It happens. Right. So in this problem, we start with 170 centimeters. And because you're starting in the metric system, right, hopefully when you read the problem, you say centimeters, inches, and that tells you I need to jump across the pond. So once you decide, hey, at some point I need to jump across the pond, you might want to look at your options. So if you look at your yellow sheet, you'll see that centimeters go directly to inches. If you have something that goes directly, high five yourself, because that's fabulous. And so we know that 1 inch is 2.54 centimeters, right? So that step, yep, high fives. I'm a big fan of personal high fives, because I don't need anybody else, right? I high five myself. So we're going to divide the 170 divided by 2.54, and that does get us, as people have noticed, 66.93 or 66.9 inches, right? not too bad. Not bad. One step. I love the one-steppers. They make me happy because they're easy. But unfortunately, life is not made up of one-step problems. So let's look at number 9 together. In number 9, we have 16 ounces is how many milliliters? Well, if you look at the volume section, right, that's the middle column about jumping across the pond, you notice that the only spot we can jump is liters to quarts. Right, that's it. That's our only option. And, well, we're starting with 16 ounces. So our first step is not to jump across the pond. Our first step is to say, I have to go from ounces to quarts. If I can't get to quarts, I can't jump. Noah, we will move decimals when we get to the metric part. When we are in the customary part, which is the ounces to quarts, we have to use those fractions in the labels. So we will move decimals in just a moment. Yeah. So when you go to ounces and you look at your paper and you say, okay, ounces. What can I do with ounces? Well, they have to be on the bottom to cancel out. But where can I go from ounces? Well, ounces will go to pounds if you're talking about weight, but you're not talking about weight, you're talking about liquid, right? So you've got to, and that's also something you have to make sure you're paying attention to because ounces can be tricky because they're in 2 different sections. So we know that there are 8 ounces in 1 cup, right? When we're talking about liquid volume. So that step there allows me to get rid of ounces, and now I'm in cups. But if you recall, cups will not allow us to jump across the pond either. I still need to get to quarts. So I need to get rid of cups. And if I put cups in the denominator, I know that 2 cups is the same as 1 pint. So by taking that green step, I can get out of cups and into pints. Well, fabulous, but that doesn't get it done either. I need to go 1 step further because 2 pints is the same as 1 quart. So finally, that orange step gets me into quarts. And once I'm in quarts, then I can jump across the pond. So our jumping, right, quarts has to be in the bottom. So 1 quart is the same as 0.9464 liters. So we had to do those first 4 steps just to get, into liters, where we were ready to jump across the pond. Okay, so can somebody do that math of 16 divided by 8 divided by 2 divided by 2 times 0.9464, right? Because that's essentially what we're doing. In the bottom, we divide Vanessa. That is not what I got. It should be 0.4732 at this point. 0.4732. There we go. And that's liters. Okay? Did you find your mistake? Good. Okay. Okay, so we have our liters, right? That was our goal right now, was just to get into liters, because now we're in metric. And if you recall, we want milliliters. So to go from liters to milliliters, I'm just going to move my decimal right 3 places, right? This is where the counting comes in. And so 1, 2, 3. So my final answer is 473.2 milliliters. And that right there is the hardest problem that you will see, right? Because you had to do extensive converting to get to quarts before you jumped across the pond before you converted again. If you can work through that type of a problem, you will be fine in these 2 sections. And the big part is letting the label guide you, right? Having your label written down and saying, where can that take me? What is the next step? What am I doing? So as long as you let the label guide you, it shouldn't be, hopefully, it shouldn't be too bad. All right. Questions about basic conversions in the US Customary, in metric, or between customary and metric? That's section 10. All right. I do recommend you practice, you watch the videos that go with the workbook, you work through those. The more you do, the easier they get. Absolutely. Okay. So now we jump into section 11. So section 11 is more converting of different types. So when we're talking about temperature, you'll notice I don't have my yellow sheet out, but it's on there. I think it's the next thing down. We get into temperature. And there are two different formulas for temperature, and they're the same thing, just written differently. Okay, so you'll have Fahrenheit is 9/5 Celsius plus 32, and then you have Celsius is 5/9 times Fahrenheit minus 32. You can use either one for every problem because they're equivalent. The key is you'll notice that within the, I call it the beef of the equation, you have a letter. So if you start with Fahrenheit, whatever you start with, you want that to be in the beef of your equation. Mathematically, it'll be easier. All right. But as long as you plug it in for the right letter, Fahrenheit or Celsius, it doesn't matter. I wanted to just stress that. So let's go ahead and do two of these and then we'll move on. So we're going to change 72 degrees Fahrenheit to Celsius. So again, it's important that you just recognize what you're starting with. So I start with Fahrenheit. Therefore, I want to use this formula because this has the F for Fahrenheit within the problem. So we say, okay, F has a value of 72. So 5/9 is 72 minus 32. Then it becomes an order of operations problem. So if we're talking order of operations, what do you do next? What's the first step in this problem? Inside parentheses, exactly. So we do 72 minus 32. Noah, that's nice. So 72 minus 32 gives us 40. So we're taking 5/9 times 40. This becomes, the multiplication division left to right. So when you plug this into your calculator, remember that a fraction bar is the same as a division sign. So this is like 5 divided by 9 times 40. And you can chuck that in all at the same time. And it will yield you a fabulous answer of what? 22.22. Very good. And that would be degrees Celsius because that is what we changed it to. Okay, twos are wild here on question number 10. Right? Play deuces wild, do a little poker action going on. All right. Okay, so why don't you guys try the next one? Change 4 degrees Celsius to Fahrenheit. So now we're going to use the other formula. Right? So we're going to use the F equals 9/5 C plus 32. So go ahead and try that one. Again, making sure you're following the PEMDAS rules. All right. So with that 4, we're going to plug that 4 in for C. So we have 9/5 times 4 plus 32. And again, we're going to use that, this whole piece is one step. So this 9 divided by 5 times 4 all should be done together, right, to give you 7.2. And then your last step is to add the 32 for an answer of 39.2 degrees Fahrenheit. So good. You guys seem to get that one. All right, so that's part of section 11 is temperature. So boom, there you go. And then we get into area and volume conversions. So remember, try to recall back from previous days. If you were finding the area of a rectangle, right? So we have the length and the width. So if you wanted to find the area, well, the area is length times width. So if these were both in inches, right, you would have, let's do an actual example just for fun. If we have 4 on this side and 2 on this side, and they're both in inches, if I take 4 inches times 2 inches, that gives me 8 inches squared, right? Our answer is square. Our units are squared because they're there twice. And you're going to have to keep that in mind when we're doing conversions, because square inches means inches are there twice. Now, when we get to volume, right, we're talking about a 3-dimensional shape with volume. Oh, I did not draw that the way I normally do. That's fine. Okay, so we're talking about volume. We have length and width and height. So volume is length times width times height. There are 3 of them. So our volume would be some number and then potentially inches cubed, because you're going to have I just lost all train of thought. You have cubic inches, right? Because you have 3, it's 3-dimensional. So again, this tells you that this is the same as inches times inches times inches. So the inches are there 3 times. So again, something to think about when you're doing conversions. All right, let's put this into practice and look at an example, because really that's why we're here. So there we go. Now, I highly recommend you write this one down, because there's a problem in web work that is very similar to this. So what is the area of a sheet of paper in square feet? Okay, well, a sheet of paper, if we're talking about a standard sheet of paper, what are the dimensions of a standard sheet of paper? Because web work expects you to know that. So you might want to, write that down if you don't know. 8.5 by 11. Yeah, so a standard sheet of paper is 8.5 inches by 11 inches. 8.5 by 11 is a standard sheet of paper. So if we're finding the area, okay, it's a rectangle. So how do you find the area of a rectangle? Right, we're going to take length times width. So what is 8.5 times 11? $93.5. Okay, so if we find the area, it's 93.5, and our label is inches squared. Because again, look at what you multiplied. You multiplied inches times inches, and that's inches squared, right? So the inches are there too. You are right, Noah, that is not feet. So we found the area with the information we were given. Now we have to convert, because remember, this section is all about conversion. So we need to change inches to feet. Okay, so go back to your thought process. How do we change inches to feet? Well, 1 foot is the same as 12 inches. But the problem is, in yellow, I have inches squared, and in green, I have inches, right? Inches squared is the same as inch times inch. I need it twice. So I'm going to take this green identity ratio and I'm going to list it twice, because now this is not stressful. Do not be stressed. Now when you look at it, you have inches times inches. There are 2 of them. So you let the exponent tell you how many times to do the conversion. You already know how to go from inches to feet. That's not new, right? And you probably never thought that was stressful before. So now you just look at the exponent and say, oh, if I have inches squared, squared is 2, then I need the identity ratio there twice, because inch times inch gives me square inches. So now when I do this math, I take 93.5 divided by 12, divided by 12. And I'm going to get a small number, I believe. Yeah. So my answer would be 0.65 square feet. And that should make sense. If you understand the concept of a square unit, a square foot is literally a square, which on each side is a foot. Well, think about what a foot is. A foot is 12 inches. So if you have 12 inches by 12 inches, that is not a sheet of paper. No side of a sheet of paper is 12 inches long. So it makes sense that a sheet of paper is less than 1 square foot because no side is a foot long, right? It's smaller than that. Okay. Okay. Process-wise, does that make sense? Okay, good. As long as the process makes sense, everything else will, the numbers will fall into place as we go. All right, so let's do a cube. And this one, there are multiple ways to do this. So we have a bag. It's 18 inches by 16 inches by 2 feet. What is the volume in cubic feet? That is not the correct answer. I don't remember who. Noah, that is not correct. Okay, so the first thing that you need to look at is that we have 18 inches by 16 inches by 2 feet. When volume is found by taking length times width times height. However, your units have to be the same. And right now they're not. So you have to decide first, do I want to change inches to feet or do I want to change feet to inches? And that's up to you entirely. So it looks like Shannon changed 2 feet to be 24 inches. And if you do that to start, that's great, because then you know the volume is 18 times 16 times 24, and as Shannon has there, 6,912 cubic inches. And it's cubed because you have inches, inches, inches. That's 3 times. However, look at the question. The question says, what is that in cubic feet? So you need to say, okay, I have 6,912 cubic inches, and I need to change that to feet. Well, think about the previous page. I know there are 12 inches in 1 foot, but my exponent is 3. So that means I need to do this 3 times. We need to do it 3 times. It's all about units because 1 inch, 2 inch, 3 inch. I need that unit 3 times to cancel out the cubic inches. Okay. So now that we have that, now I can take the 6912 of cubic inches, divide by 12, divide by 12, divide by 12. And you should get 4 cubic feet. Correct. Now, it is possible, if we go back to the original question, if you change each of these to feet first, you could have done it that way as well. All right, because 18 inches is 1.5 feet and 16 inches is 1 1/3. The only issue is you have to, if you're changing it to a decimal, you have to round that. And as soon as you start rounding, it gets a little ugly. So in order to keep your answer as exact as possible, going to inches first and then cubic feet is actually a more exact way in this case. So you really have to pay attention of that exponent is going to tell you how many times you have to do that. Okay. All right. Now we are getting into special cases. So I still have quite a few slides, but we'll just work until 1 o'clock and that'll be the end of class. We may or may not get through all of them, and it'll be okay. So this special case is dealing with a cylinder. So a soup can, think Campbell's soup or anything that's cylindrical in shape, is 5 inches tall with a radius of 2 inches. What is the volume in cubic centimeters? So if we're dealing with a soup can, which is cylindrical in shape, hard to draw three-dimensional shapes with a mouse. Okay, so it's 5 inches tall. The radius is 2 inches. Remember that when we're talking about a cylinder or a circle, the radius is from the middle to the outside. If we have a circle and we go all the way across, that would be the diameter. So it is important that you kind of have those terminology-nesses in the back of your head. So the radius is from the middle all the way to a side. Now, do any of you know the formula for volume of a cylinder? And if you don't, I do believe it is on the bottom of your yellow sheet. It does involve pi because pi is dealing with circles. So look at the very bottom of your yellow sheet. You should see pi r squared times the height. All right, because pi r squared is the area of the circle, which is the base of the cylinder. So if you find the area of the base and then multiply by how tall it is, that will kind of, volume is if you're filling this up. So you find the area of the base, multiply by how tall it is, that'll tell you how much you can actually stuff in this can and to fill it up. So pi r squared. Now, WebWorks should be set up to allow for tolerances of pi, because remember that pi is the same as roughly, well, it's approximately 3.14. So you can use the pi button on your calculator, or you can just estimate 3.14, depending on what you use. And I don't remember what I used on my answer key, so we're about to find out here. So if we look at this problem, we've got pi times the radius, which is 2, squared, times the height of 5. And remember, these are all in inches. So what is pi times 2 squared times 5? Roughly 62.8. I'll take that. And what's my label? Cubed. Very good. Inches cubed. And if you wonder why, well, look at this. The radius is squared, so the radius is 2. So that's 2 inches times 2 inches, and then the height is 5 inches. So it's cubed because the inches are there 3 times. Okay, so I found my volume to be 62.8 cubic inches. Okay, and again, a cubic inch, I mean, that's, if you have a cube, it's an inch on each side. So think about, well, little sugar cubes, those are smaller than a cubic inch, but that's an idea of, or a dice, right? That's, a cube. So you could think about fitting 62.8 cubes in this box. Anyway, the question says cubic centimeters. So how do I go from cubic inches to cubic centimeters? Think about inches to centimeters. How do we do that? Either you guys are all working or you're all ignoring me. I don't know. I guess either way is fine. So remember that we know 1 inch is 2.54 centimeters, right? So that's our conversion that we're using. But how many times do I need to do this green conversion? 3, exactly. You guys aren't ignoring me. You're good. All right, so we have to do that 3 times because we're talking volume, and volume is cubic units. So it's the same thing 3 times. All right, and again, the reason we do that, 1 inch, 2 inch, 3 inch gets away with cubic inches. So now I'm going to, everything's in the numerator, right? So we multiply all the way across. So if you multiply all those together, we rounded slightly differently than we did on my answer key, so you guys are going to have to give me the answer on this one. right, so let's just deal with 1,029 cubic centimeters. I love it. Love it. Everybody good with that? Multiplying straight across, centimeters cubed, cubic centimeters. All right. Now, any questions on how we got any of these numbers? I do things in different colors for a reason. That way, if you say, I don't understand where the green numbers came from, or blah, blah, blah. So are there any questions on this page with any of these colors? Gone once, gone twice, sold to everybody saying no. All right, so 1029 is our answer. Okay, now let's change that to milliliters. So remember, our answer is 1,029 cubic centimeters. Go to your yellow sheet. I hope you guys have your yellow sheets. That makes this easier. So underneath, we're now in the sixth one down where it says special conversions. In the first box under special conversion, you see 1 cubic centimeter equals 1 cc equals 1 milliliter. So to change from milliliters or cubic centimeters to milliliters, it really just is 1 cubic centimeter is the same as 1 milliliter. Well, thinking through the mathematics of that, your cubic centimeters cancel out. Multiplying by 1 doesn't change anything. So my answer is still 1029. The label just changed from cubic centimeters to milliliters. So if you can picture, one of those little sugar cubes, which really are probably pretty close to being a cubic centimeter, that's like a milliliter of liquid. So when you think about a cc, because that's like in the health field, right? They, watch Grey's Anatomy. I need 5 cc's of blah, 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 blah. That's what it all sounds like to me. That's what a cc is. It's a little cubic centimeter in terms of size. And that kind of gives you a better idea of, a milliliter of liquid, what that looks like. Okay. So sometimes it's fun, I think, to be able to visualize what this crap actually looks like. All right. Good, good. Let's see what's next. It's like Christmas. We are not going to do that question. Oh, crap. We're going to skip these for now. If we have time, we'll come back. Amanda, where do I keep the yellow? Amanda, the yellow sheet is page 245 in your workbook. So you might want to reference that. That is the formula sheet that will be used on the exam. So page 245 is an easy access. That way when you have, when you're doing web work, you don't have to flip through back and forth. Yep. Very good. Okay, so we're jumping ahead to talk about rates. So up to this point, all of our conversions have started with just a single number in the numerator, and that's been it. Well, now we're going to rock your world and, maybe make you a little angry. So channel that and go with it. So I ran 5.3 miles per hour. What is this in meters per second? So when you look at this, we see the word per. So go back to the first unit where we talked about the word per. And when we saw per, what did that inspire us to do? You're definitely inspired there. It's the fraction bar, right? So we can say that this is the same as 5.3 miles. Per implies the fraction bar. And then per, remember per means per one. Think about per capita. Over 1 hour. So we are now going to get into rates, which have labels in the numerator and in the denominator. I know. So not only are you going to convert in the top, but now you can convert in the bottom too. I know life is so good right now. So when you look at what we're trying to find, right, we want to be in meters per second. So not only do we need to change the numerator, but we need to change the denominator. So, I hope it's okay. I'm not going to ask too many questions because we are getting ready to run out of time. So when we look at this, I need to change miles to meters. I need to change hours to seconds. I'm going to change hours to seconds first because I feel like that's going to be easier. I know that I can go from hours to minutes. And because hours is currently in the denominator, to get rid of it, I need to move it to the top. Because again, we're talking about reducing our labels. So I know that I can change hours to minutes. 1 hour is 60 minutes. So that yellow step gets me out of hours and into minutes. But I don't want to be in minutes. I want to be in seconds. So I know that 1 minute is 60 seconds. Again, minutes have to go in the top because I need them to cancel out. Minutes in the bottom, canceling out with minutes to top. I am now in seconds. That's where my denominator wants to be, so I feel good about it. So now I can start in on the numerator and think, okay, miles. I need to get rid of miles and go to meters. Well, I can go from miles to kilometers. So if I think through that, I know miles is in the top over here, so miles has to go in the bottom. And I know that 1 mile is the same as 1.6093 kilometers. Right? So that green step allows my miles to cancel out. And now I'm in kilometers per second. I know that's not where I want to be, but I know that to go from kilometers to meters, I'm going to move my decimal right 3. If you think back to when we did that problem earlier. So my last step is going to be to move my decimal right 3. So I'm going to start by saying I have 5.3. I'm going to divide by 60. I'm going to divide by 60. And then I'm going to multiply by 1.6093. Now, if you want, you can move a decimal in any one of these numbers over 3. It'll do the same thing. But when I multiply those numbers, assuming I did my math correctly, I should get 0.002369, blah, 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 blah. Right? It goes on and on. And that is kilometers per second. But that's not what I want. I want meters. So I take this answer, and again, I move it right 3. 1, 2, 3. So my final answer is 2.369 meters per second. Again, there are other paths to get there, to go from miles per hour to meters per second, but this is a methodical way that we have done throughout the class already. Okay.
On web work, there's a problem that talks about like miles per gallon to like liters per kilometer. Would that be like the same as what this one is asking?
Yeah. Can you say that? Say it again. What they're asking for? Miles per gallon.
I have it written down. Like I think it was like 22 miles per gallon, and then what would this be in liters per kilometer?
Kilometer per liter.
Yeah.
Yeah, same exact thing. Absolutely.
Okay.
Because if you look at it, you know, we can go from miles to kilometers, right? We know it's 1 mile is 1.6093 kilometers. Yeah, so that puts me in that label of where I want to be, and it makes my miles go away. Then when you think gallons to liters, you have to jump across the pond, right? And to get to liters, only from quarts to liters can I jump. So your first step would be to go from gallons to quarts, right? Noah, run into questions like this. These would be considered, I would say, a little bit more difficult questions. So you might run into maybe 2 in your homework and maybe 1 on the exam. If that, I don't remember what the exam exactly looks like right now off the top of my head. But these are not the run-of-the-mill regular ones. These are the more advanced. But they're really, it's what we already did. Now you're just doing it twice. So instead of just going from miles to kilometers, now, and then gallons to liters, you're doing it at the same time. And it just kind of goes from there. And it's all about placement, right? So if you go another step further, if you want to get rid of gallons, gallons have to go on the top. So 1 gallon is 4 quarts. It's all about just making sure that your label is in the opposite position and filling in the numbers as you go. Yeah. Yeah, there's a benefit of looking at the web work before class. Absolutely. Good. Okay, it's 5 till 1. We haven't gone through all of my slides, but that's totally okay. I do want to do one more, if you're okay with that, which is a dosage problem. This problem here is going to be very much like that dosage report that you need to do. Okay, and you can do it either by hand or type it in, or you can set it up in Excel. Some people really like to use Excel. That's up to you. So we're going to run through this one so that you have an idea of what that dosage assignment should look like, and then we're going to call it a day. So Steve weighs 188 pounds. His drug dosage is 25 milligrams per kilogram to be given twice a day. How much is in each dose? Right? So this is you know, and it's the same process that we have been using. So you think about, okay, we know that he's 188 pounds. But the problem is, and maybe you've already noticed this, wrong button, the dosage is 25 milligrams per kilogram. Well, I don't have his kilograms, I have his pounds. So our first step is to get him out of pounds and put him into kilograms. So we know that 1 pound is 0.4536 kilograms. And again, I want to stress using the conversions on the yellow sheet, because that is what WebWork and everything is built off of. So if you use other known conversions, your answers are going to be slightly off because of rounding, and which could cause problems. Okay, so once we have kilograms, right, this will tell me how many kilograms Steve weighs. Then we can figure out his dosage, because the dosage is a ratio. 25 milligrams per is the fraction bar per kilogram. So the dosage will tell me how many total milligrams of drugs Steve should get based off of his weight. Now, if you do that, you get an answer of roughly 2,132 milligrams, if I round. Is that my final answer? No is the correct answer, and why not? It's given in 2 dosage, exactly. So this number here in red is the total dose for the day, right? That's the total in the day. The question is, how much is in each dose? So if it's given twice a day, then we have to divide by 2. So if we divide that by 2, then Steve should get 1,066 milligrams per dose. And so your job in this report that you're going to do, and it's not, I mean, it's nothing fancy. Answer the questions. I'm not looking for a super fabulous anything. Just answer the questions, and you'll be fine. Is, you know, you have a list of patients and how much they were drugged. Were they overdosed or underdosed? And there's, you know, rounding is fine. You might be 1 or 2 milligrams off. That's fine. It's, if this person was supposed to get 1,066 milligrams per dose and they were given 3,000 milligrams per dose, you know, you could kill somebody. So that's the report is, who's being overdosed and why and how, that kind of a thing. So this is kind of the process that you'll go through when you're doing that dosage calculation report. Okay. And it is now 12:59, so we are officially done. I'll stick around for a few minutes in case anybody has questions, but otherwise, a lot of math in sections 10 and 11. So get in there, get working that way. If you have questions, you can get those to me and we'll have time to work through things. So thanks for coming. Thanks for being engaged and doing good work. And let me know if you have questions. Otherwise, I will see you guys next week. Thank you.